Now let us submit the jobs. Okay, so let me run this command. So I'm getting the virtual cluster ID for the team C. This is the role name and this execution role ARN, and I'm submitting AWS EMR container. This is the AWS EMR API, and starting the job on this virtual cluster, and the name of the job is Spark PI, and the the code is basically within the S3 bucket. Okay, and there are few configuration for the number of executors, CPU, memory. All of that is a typical Spark configuration. So let me just run this job. Okay, and see it triggers the Spark job in the cluster. So the job is submitted. Now let's go to the console and check whether the job is running or not. Okay, and we run this job for the virtual cluster C, and here if I go to the job, right, jobs, there is a submitted status. So this just now submitted and a few seconds ago, and let us wait for some time. I'll take a pause. It will take a few minutes to complete this job. So while the job is waiting, let's understand the parts which are getting created, right, in the namespace for team C. So if you see, there is one part which is getting started fast. So this is the job submitter. Okay, this is not the driver part. So the submitter will make a call to the control plane in the cluster mode with the Spark submit API, right? And then that will trigger the creation of the driver pod. So you see the driver pod, and then which in turn will create the executor parts. Okay. Now here I didn't specify any specific requirements to schedule these pods on, for example, spot nodes or on demand. I just made it generic so they can run anywhere. So now you see the executor pods are already scheduled and they are completed. Now if you see the IPs also, this is a pod IP and this is node IP. The pod IP is from 100 series, the node IP is also from 100 series. Okay, so that means they're using secondary siders. Okay, now you see that the job is completed, and so they will be terminated, eventually, and they will be cleaned up also. You see in the completed state. So if I come back to the job status, so it is completed, and you can also see the Spark UI for this particular job. Okay, now in open source based data platforms, so we have to manage a lot of things, right? For example, the Spark operator we have to deploy, the Spark history UI server we have to deploy in the cluster and manage that on a daily basis. Now here it's not required. Everything is completely managed through the EMR and EK service, which is a lot of operational overhead for the DevOps teams. Okay, so it's a fully managed experience. How much of time each step took and what is the time for the shuffling, all of that you can debug, just like you use the typical Spark UI server. Okay, so this is how you can schedule the jobs using the EMR and EKS service. So in this demo, let us talk about fault tolerant with EC2 Spot instances. Okay, so the Spark jobs that get scheduled can leverage the EC2 Spot for cost savings. So that means executors can be run on the Spot instances while the driver spots are running on the on-demand. Okay, and in our cluster we had one Spot instance. So for example, if I go to the EKS cluster, I have two node groups, one for on-demand and one for Spot. And one Spot node group has one node, on-demand has four nodes. Okay, so I can actually run this command, get nodes, show labels, grep with capacity type and Spot. I can see one node is already available. Now let's go and run this job, which will trigger the Spark application and use the Spot instances. So before we run the job, it's important to understand how to simulate the Spot interruption. So for that, we are using FIS, which is basically the fault injection service from AWS, right? So I'm creating one experiment. That's what we call. Two experiments are basically the templates to run trigger some actions. So basically, I'm using a EC2 Spot interruption action ID, and for 2 minutes I need the interruption for, right? The moment the interruption comes, after 2 minutes the instance will be terminated, and the target will be Spot instances, and only one of them I want to terminate. And So how do I determine which spot to terminate? Based upon the tags. So the tag will have the cluster name of our cluster, because you do not want to terminate the other instances, right? Only your cluster. So this is how I created, and it looks like this in the console. Let's go to the FIS console. So the experiment looks like this in the resiliency hub. If you go to the experiment templates, this is what we have created. And when the job is running, we will terminate the EC2 by triggering the experiment. So let us first run the job. So this is how we are submitting the job, just like earlier in example also. Here we are using a different pi dot py. This is a pi application which is already there in the local file system for the containers, for the executors and the driver. And see, we are mentioning the extra parameters for the application configuration, right? Capacity type on demand should be used for the node selector. For the driver, executor should be spot. Okay, and so let us submit this. So in fact, the submitter is also using a capacity type on demand. Okay, the executor, only executor will be using the on demand, sorry, spot. So let us first copy this, run this command. Okay, the job is submitted. Now these are my nodes in the system, and this is where the new parts are getting created. Let us wait for the executor to start first. Okay, we are still seeing the job submitter, and then we will we are seeing the driver next. After that, we will be seeing the executors. The moment the executor part starts, we will do the simulation of the interruption of the spot. So that way, we wanted to ensure that the job gets interrupted due to spot, and then it will automatically recover. Okay, so this driver pod is running, just getting started rather. After that, the executor pods should start. Let us wait for a second. So the driver is still running. Let us give it. Yeah, executor just started. Now they will be getting scheduled onto the spot instances. Let us go ahead and terminate the spot. Okay, um, they're just getting created. Now I will go here and start experiment. Okay, so start experiment. I'll say start. You see that the node is scheduled disabled because the interruption is received. The spot instance is now getting drained and corded and drained, and a new spot instance will be automatically created. And this is how our parts are also getting terminated, because the spot is getting got the interruption, the node is getting drained, the executor parts on that are getting terminated, and the moment a new node comes up, we should be able to see the executor parts getting recreated. So let us give it some time. I'll take a pause. So while it is waiting for the spot to go and come back, so we see that the job is still running. Okay, so Spark inherently handles all of that interruption without our notice. So the job is still running. It may take some time, but it is still running fine without any issue. So if you see, we got a new node which is just launched a few seconds ago. And if you see, the executor pods are now getting created on these nodes, the new node, and they'll be start executing it. Okay, so that's how you know there is no issue even if there is spot interruption, right? Mm. So if you go to the nodes, so this is the new node, and that's where the executors are now running on the new node. Okay, and they're running now. So let us give it some time to complete the job. So if you look at the job status in the EMR console, you still see that the job is running. There's no interruption. It is taking few minutes extra, but it is still running fine. Okay. So we now see that the executor parts are getting terminated. So it looks like the job is completed. Now the driver parts also will be completed. Yeah, it's completed state. So the job will be completed now in the EMR console also, the latest status. And yeah, so this is the new node that we saw. Okay. So this was the old node and this is the new node. If you see a few seconds back, it was ready. So all this is fine. Okay. Now, if you go to the EMR console, you see that the new job completed, the recent job, and it took 5 minutes because of the Spot interruption, but there is no issue. So you can go to the Spark UI and debug which particular stage took time, right? So all of that you can verify that. So this is how you can basically use the FIS, which is a fault injection simulator service, to inject Spot interruptions to the EC2 Spot machines and then simulate the failure. So with this, we conclude the demo for running the Spark jobs on EC2 Spot and then using the FIS to simulate the interruptions. Okay.